like, oh yeah, I remember that. As opposed to some of the stuff we did earlier, which was at the beginning of the year. But we'll see. The word that is remaining the same, Jair, in this unit is quadratic. 2 units ago, we covered quadratic expressions. What did we do to quadratic expressions? Huh? No, we did not solve expressions. What did we do? We factored them. Yeah, we factored them. Last unit, which you just took a test on, we covered quadratic equations. What did we do to quadratic equations? That we solved. Okay. Now we're going to move to quadratic functions, which primarily what we're going to do is graph them. But that's kind of a weird type of approach, because since I try to structure this with as much multiple choice as possible, you know, other than maybe on the homework, you know, you're not going to be responsible for too much graphing, but you're still going to have to be able to identify key components of a graph. You know, when you have something multiple choice, you don't draw the graph yourself. The graph is drawn for you. We have worked with functions this year, but they were linear functions. And linear functions also had forms. Just for fun, can you remind me what some of the forms were for linear functions? That's funny because he said words. What were some of the forms for linear functions? Slope-intercept, sure, that's the big one, yeah. Standard, which coincidentally we have another standard here, yeah. And one more. Point slope, and point slope was the other one. So quadratic functions have some forms. We're just going to cover the main two. One of them is standard, which is today. Another one's vertex, which we'll do on Monday, vertex form. There is another form called factored form, which we've kind of, since we've already done factoring, we've already like, here, look, this is standard form of a quadratic function, right? So all we're really doing is throwing this f of x equals in front. A function is most like an equation because we still have an equal sign. But now instead of just having an x, we also have an f of x. And what else can f of x be rewritten as? What does f of x mean? When you see of f of x, what does that mean the same as? If we're going to be graphing, you can take an educated guess that we have an x, and now we're throwing in an f of x, and that f of x also means if you are graphing and you have an x already, now there's another thing showing up. What do you think that other thing is? A y. Very good, yes. F of x just means the same thing as y. So, you know, all factored form would be is instead of this that you're used to, this ax squared plus bx plus c, you would have factored that side already with the parentheses, which we spent an entire unit on. What factored form is good for is x-intercepts. If you want to know where this is going to cross, the function is going to cross the x-axis, factored form helps. But we're going to focus on the other two. So starting with standard form, we should already know how to identify a, b, and c. That's going to be the same as it was with expressions and equations. A is what's in front of x squared, b is what's in front of x, and c is a constant. But in order to move forward, and you guys have an advantage because even if you didn't learn much, you've already taken Algebra 1 before, is understanding what type of a shape a quadratic function takes. You have to put your bone next to your phone. What type of shape does a quadratic function look like? When I graph a quadratic function, what does it look like on the graph? Seabass, you want to take a guess? Yeah, you don't remember graphing quadratics? There you go. Well, every other class today got this. Just one person. Well, yeah. Well, what the other two classes said today was, "Hey, Mister, it looks like a U," and it could look like an upward or a downward facing U. But yes, what that is referred to is a parabola. That is called a parabola. Parabola. Okay. So, arguably the most important point of a parabola is where the parabola changes direction. A parabola is either headed down, 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 and then up, or up, 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 and then down. That point where you change direction either down to up or up to down is known as the vertex. The vertex is going to be much more easy to find once you learn vertex form. Similar, like we talked about other forms like linear, for linear function, when we had forms like, y equals mx plus b. Well, there it was really easy to find the slope and the y-intercept because they were basically already given to you. So once we get to vertex form on Monday, the vertex is just going to be given to you. But today, if you need the vertex, which you will, you're going to have to find it. A vertex is a point. Points have x's and y's. But for the vertex, we call the x, specifically we call it h. That's here. H, comma k. And we call the y k. Just of that one point. For that one vertex, we call the xh and the yk. The first one you would find is h, and the way you find h is negative b plus 2a. If you know what a, b, and c are, you do negative b over 2a. And that gives you the x coordinate of the vertex. The most work you'll have to do today is to find the k. And not that it's a ton of work, and I'm going to show you a shortcut. But you're supposed to get this, whatever you get for h, you're supposed to get it and plug it back into the function. Which means since these are x's, since h is an x, we're supposed to get it and plug it in for the x's. But I'll show you a quicker way to do that. You're going to have to pay attention. But if you can't pay attention, even if at first you're like, what? That's weird. I don't get it. I promise you, you'll get it by the time we're done. That's what all the kids say. Jair says it too. Another thing we'll learn about parabolas is that they're symmetrical. Parabolas have vertical symmetry. I can draw a vertical line right through the vertex, and the left and right side of the parabola will be a mirror of the other side. And we can use that to our advantage when it comes time to graph. That vertical line is known as the axis of symmetry. Feel free to write that in if you'd like. Axis of symmetry. And because it's vertical, like any other vertical line on a graph, that's going to start off with x equals. Any vertical line on a graph only has an x, it doesn't have a y, so it starts off with x equals. And it's supposed to be x equals h. But since we just learned up here that h ends up being negative b over 2a, whatever number I get there, that's what I'm going to put in. Of the two forms that we're going to study, when it comes to graphing, you'll probably find vertex form to be the preferred method, just like you found slope-intercept to be the preferred method in linear, because you're just given the vertex. You always have to find the vertex, and there you're given it. But you can get something from standard form too, Thea. It's not as nice as the vertex, but from standard form, you do get the y-intercept. Every parabola has to have a vertex and has to have a y-intercept. The thing is, you have to graph the vertex. You don't have to graph the y-intercept. If you do want the y-intercept is always going to be located at C, wherever C is. That'll be your y-intercept. You looking forward to diabetes one day? much sugar. You're fasting. You're on a strict sugar diet. All right, let's start doing some examples. Okay. This first page is just to get us oriented with a vertex and what it is. What is a vertex? By the way, this is a 2-day lesson, so we don't have to cover everything today. Tomorrow we will go over the test and try to finish as much of this as possible. So, what's our next quiz? It was supposed to be Wednesday, but I'm pretty much already decided I'm going to cancel it. So, I'm not going to be in class. I said, two main reasons. One is I don't have enough problems to populate both a quiz and a test for this unit. The second being you already have the performance exam. I'm sure you guys are tired of testing anyway. So, hi, Asmer. Thanks for driving. So if I, not that you have to do it this way, but look, watch. If I were to go and draw a point at all of the vertices, the vertexes of change of direction, what they're asking me to do first is to identify where that is. So let's just go ahead and do that for all of these. Where is the first vertex at? What point is the first vertex at? It is at 1, -2. Thank you, Lord. Where's the second one at? -2, 4 will work. Where is the third vertex at? Say it again. Yeah, 4, 3 is good. And then where's the fourth one at? -3, -3. Any questions so far? Well, a word that can be used interchangeably with vertex is minimum or maximum. When you see those words, either one of them, they are talking strictly about the vertex. That's a little bit more specific. Really, if anything, they're talking more about the y of the vertex. Because a parabola will open up forever to the left and forever to the right. But when we're talking about the minimum or maximum value of the function, we want to know how high or how low. A parabola is either going up and then comes back down, or going down and then come back up. We want to know how high and how low. But fine, just associate it with vertex, right? So the thing is that if you go back and look at the first one, is that an upward or downward facing parabola? It is facing up. And because it's facing up, is the vertex then at the bottom of the parabola or at the top? And because it's at the bottom, that vertex would be the bottom of the parabola. If the parabola opens up, we have a minimum. Look at number 2. Is that vertex at the top of the parabola or at the bottom? At the top. Therefore, the vertex would be a max. Now, on both of these, if I were to elaborate on that, like for the first one, ask you, hey, what is the minimum value of the function? What would you say? For number 1, what is the minimum value of the function? Yeah, because really when you use those words instead of vertex, you're really talking about the y. This first function has no maximum because it goes on forever. So there is no maximum value, but there is a minimum. The lowest it goes is -2. If I go to the second parabola that we did, what is the maximum value of that function? No, it's 4. Because it goes as high as 4. There's no minimum because it'll go down forever and ever and ever, but there is a maximum. Look at number 3. Does this have a max or a min? This would be a max because the vertex is at the highest point. And then if you were to be asked what that max is, what would you say? No, not 4. It would be 3. And then now that we look at number 4, does that parabola, I'll say, have a maximum or a minimum? It does have a minimum. And where would that minimum be at? It is at -3. Okay. So now we get into the nitty gritty, and this is basically what we'll do for the rest of today and for tomorrow. Let's get to the graph. Now, to be perfectly honest, what I care more about than the graph is this. Are you able to answer questions about the graph without actually being able to see the graph? Especially in this case, because since I structure myself with multiple choice, you are more likely to be given these types of questions. This lends itself more to multiple choice than does asking you to graph something. You will have some graphs, and we can be creative about the way we put them on there, but I care more about this. So let's start off on the right side. We'll graph afterwards. If you look at all the stuff you're being asked for in that little box on the right, which ones do you think would be the easiest to answer? The domain is actually going to be the easiest, but I haven't mentioned domain once yet. But yes, domain probably you could argue is going to be the easiest one of all. But let's leave that one. We'll hold off for right now. Based on what I showed you on the first page. Look at that. She had her head down. Very good. Yeah, the y-intercept. Why would it? Because what form is that function in that they want me to graph? What's that about? Slope-intercept is for lines. What form are we learning today, man? Standard form. Yeah, it's the standard form. So A is 1, B is 2, C is negative 4. And why did Althea say the y-intercept? She's smart. Because she's smart? No, because, well, that probably has to do more than she's paying attention than her being smart. But what did I say about the y-intercept on the first page? It is going to be C. So my y-intercept here is going to be... He actually hasn't looked at the paper yet, much less pay attention. So it's a work in process. Huh? I'm talking about the jelly beans. Okay. Again, I still agree with Jose. Probably the easiest thing to answer out of all of this is domain because it's gonna be the same every time, no matter what. But let's just hold off on that. Let's talk more about what we talked about already. So the next thing I would tell you to answer is this. Opens up or down, minimum, maximum. What reveals that is A. More specifically, the sign of A. A positive, parabola opens up. A negative, parabola opens down. In this case, A is positive, so is this parabola going to open up or down? Up. It's going to be up. And here's where the children struggle because this is where you actually have to learn something. Assuming you get that part right and you understand that this goes up, we're not talking about the function, we're talking about the vertex. These words mean vertex. So on an upward facing parabola, where is any vertex going to be located? On the bottom, which would make this a minimum. Anytime your answer is up, the other answer has to be minimum. It's going to be a minimum. Anytime your parabola opens down, you have a maximum. Okay. Now let's move on to domain and range, more specifically domain. We should already know that domain means what are all the x's on a function. Range means what are all the y's. Okay. Now, really, of all these questions, probably the last one you're going to answer is range. Because range is dependent on the vertex. However high a parabola goes or however low a parabola goes depends on where the vertex is. I cannot answer range without knowing the vertex. But I can answer domain because for the second time, it's always going to be the same. Is it allowed? No, it's always going to be the same. Because every parabola, even though it looks like arrows might be pointed straight up or straight down, that is not the case on every parabola. the arrows have to be pointed slightly outwards. So if you give a parabola Jair enough space, that parabola will open up forever to the left and open up forever to the right. So your domain is always going to be what we call all real numbers. That's a symbol for real numbers. It's like an R with like an extra stick. If that's what you want to write for me, that's fine. But in order to keep things in line with, the way some other teachers teach this, and probably the way you'll see it on the final, let's write this in interval notation. We saw interval notation earlier this year, and with the previous teacher if you had a different one. What's the lowest the domain will go? Negative infinity. What's the highest it'll go? Positive infinity. Parentheses. And you will see that every single time. I always laugh when we get these. And actually, I think on my test, the one I have, I probably won't even ask you for domain, but last semester, some of the questions did reward you for domain, and people still got it wrong.
Yeah, I did it.
Yeah. Oh, look at that. You know something to do every day.
You were like a year ago.
That was like last year, though. That was like a long time ago.
That was like a year ago.
All right, so we got 3 left to go. All of that depends on vertex. So sadly, we've reached the point now we're going to have to find the vertex. The vertex we identify as h, comma, k. So it's an x and a y, but just we call the x h, we call the y k. We're going to find the h first. What is the formula I gave you for h? In order to find h, and this is not on the reference sheet when you take the final. What is the formula I gave you for h? What is the formula I gave you for h?
Oh, wait. H, negative b, 2a.
Take that, Althea. Negative b over 2a. If b is 2, then negative b would be negative 2 over always a 2 times a, which is 1. 2 times 1 is? Negative 2 divided by 2 is negative 1. I'm not sure if this is the approach I should take, but let me try. Maybe this will help you pay attention and stuff. I am not done with the vertex. I do not know the entire vertex, but if I were to go back, like if I were to keep a running list of what I now know, I now know that the x of the vertex is negative 1, but I still need the y. And what does AOS stand for? Axis of symmetry. I actually know that because the axis of symmetry you were told was x equals h. And I now know h. So I would just write x equals. Remember that the axis of symmetry is like a mirror. It's an invisible line where on either side of that line, the parabola looks like a mirror image of the other side. If I were to draw that now, I told you I wanted to leave the graph for the end, but might as well just draw this now. If I wanted to draw the axis of symmetry now, I would find negative 1 on the x-axis and draw a vertical line right through it. Parabolas have vertical symmetry. So whenever I graph the vertex, it's going to be on that line. Even though this is the boringest thing ever, or at least the boringest thing since yesterday, the hardest thing you'll find today, if you want to call it that, is finding k. That's the one that requires the longest process, but it isn't. I'm going to show you a shortcut. You just got to follow it. Okay, ready? Let's find k. What you're supposed to do, and if you had a different teacher before, what they showed you to do is to get this negative 1 and now plug it into the x's. If you want to do that, go ahead. I don't have a problem with it. I find people make mistakes with signs, people make mistakes sometimes with calculations. They just don't know how to substitute. So here's an alternative. There's something called synthetic substitution. Get the number that you want to plug in, which is? What number do I want to substitute? What number do I want to plug in? I just drew a circle around it and drew a bunch of arrows.
1.
Not 1, negative 1. Okay. Then you're going to write A, B, and C right next to that. A is 1, B is 2, and C is -4. The only time where this could get slightly tricky, every parabola has to have an A. That there has to be a number where A goes. But it technically doesn't have to have a B or a C. So if you ever have a B or a C that's not there, you have to write the 0 in its place. You have to have one number here, and you have to have 3 numbers there. Then we're going to give a little bit of space, and we're going to draw a line. Think of these as being like columns. There's an A column, a B column, and a C column. Underneath the line at the bottom of the C column is where K is going to show up. This is where K is going to be. You don't have to draw all these extra things. I'm just trying to help you visualize. So here's ready. Here's the path I'm going to follow. I'm going to trace the path. I'm going to start off with A, and I'm going to go down, up and to the right, down, up and to the right, and down, until I get the K that I want. Every time I go straight down, I have to add the number that's already up here, and then the number that's going to be underneath it. Every time I want to go up and to the right, I have to multiply with this number here. The analogy I've given in the past, pretend that number is like Rapunzel up in the tower, and it needs to pull something up. So every time you need to climb up above the line, Rapunzel needs to help you. And when Rapunzel helps you, it's always multiplication. You know Rapunzel? So do you. First thing we're going to do is go straight down. That's the first path. I told you straight down was adding, even though you really don't have to think of it that way. But when you're adding, what's beneath the 1? What's right underneath the 1? Nothing. What's 1 plus 0? So for all intents and purposes, what happens is the 1 just drops. It goes below the line. Now I have to go up and to the right. What operation did I tell you we're doing? We go up and to the right. What operation did I say we're doing when Rapunzel wants to pull you up? What operation are we going to do? It starts with M and ends with multiply. We are going to multiply. So what is this 1 that I just got down here times -1? What does that give you? What is 1 times -1? 1. No, -1. And now I want to go straight down. I just add. What is 2 minus 1? -1. Every time I want to go back above the line, what do? Multiply. So -1, the Rapunzel times 1 is -1. And finally, when I add -4, -1 is -5. Congratulations. K. K is going to be -5. If that's too hard for you, fine. Don't learn it. Go plug it in the long way. It's going to give you the same. So now I know the second coordinate for my vertex, and I actually also know the range. Range has to do with y. Let me write it down here because I'm going to end up writing it in. I'm going to end up writing this in interval notation. So range has to do with y. On the other side, I'm going to put the k, whatever I got for k. And in between, it's either going to be a less than or equal to or a greater than or equal to. If the vertex is at the bottom of the graph, where are all the rest of the y's going to be? If my vertex is at the bottom, where are the rest of the y's on the graph? Top, above it. So this is going to be y greater than or equal to -5. That's one way of saying. We already said out there this is an upward facing parabola. We just finished saying over here that the lowest will go. We just found out is going to be -5. So if the lowest we go is -5, where are all the rest of the y's? Greater than or equal to -5. But let's write this in interval notation. On an upward facing parabola, the arrows go up. We're going up forever. So the second number is going to be that positive infinity again. And you got to go from least to greatest. But what's the lowest it goes? Huh? -5. So that's going to go first. Do we actually touch -5? Yeah. So you got to put a bracket instead. Okay, now let's try to graph. The point that has to be on every single parabola you're going to draw is the vertex. The vertex is at -1, -5. And notice how, sure enough, it does land on the axis of symmetry. The number that we're shooting for here is 5. I want to plot 5 points. So far, I got 1 down, 4 to go. Do I happen to be lucky enough to know any other points that are going to be part of the graph? Are there any other points that I happen to know are going to be part of this graph? Sometimes you'll know some, sometimes you won't. In this case, I do. What other points do I know are going to be part of the graph? The y-intercept. Now, see, if that y-intercept, like every function has to have a y-intercept, except for rational ones, but that's the but if they were to tell me that my y-intercept was at 52, well, that's not going to help me very much because that's way up too high. It's not going to really help me. But since this was at 0, -4, I will put a point at 0, -4. 2 points down. 3 to go. I can now use my axis of symmetry. How far away is that one point that I just put from the axis of symmetry? The y-intercept, how far is it from the axis of symmetry? Here's the point I just put on the y-axis. Here's my axis of symmetry. How far away are they from each other? How many units? How many spaces are they away? 1 space. So I can then take advantage of this and say, okay, well, that means I'm going to have a point 1 space away on the other side. That's 3 points down. 2 to go. Well, I need some help finding the other points. You just finished telling me that the points that we put on are 1 space away. I need to find some other points that are a different amount of spaces away. You could go 2 spaces away, 3 spaces away, 4 spaces away, but understand that the further away you go, the bigger your graph is going to get. So assuming you want to keep your graph small, let's go 2 spaces away. Let's see what point would fall 2 spaces away from the axis of symmetry. Where else could I put a point there? So here's the trick. I never used to teach it this way, but I think some of the teachers here do something similar. How many spaces away do I want to go? 2, so I'm going to write a 2. What type of function is this? Huh? What type of function is this? In the title of the lesson. Standard. No, what type of function is this? Linear. There's a word that goes with it. Quadratic. So I'm going to get that 2 and I have to square it. And then the one more thing I have to do is multiply times A. What does A happen to be here? 1. So I picked the 2, and really what that 2 means is, let's just say to me, let's go 2 to the right. What is 2 squared times 1? It is 4. So what this is telling you is that's a positive 4, it goes 4 up. But from where? From the vertex. So if you were to start up the vertex and go 1, 2 to the right, and then 1, 2, 3, 4 up, put a point there. That's 4 points down. I want 1 more. That new point that I just put, how far is it from the axis of symmetry? 2 units away. That was the whole purpose. 2 units. So then just go 2 units on the other side, put a point, and we're so happy. There's our parabola. Let's try to at least get one more done, because tomorrow I'm going to start with the third one. Here's another one. Let's do the right side first. Well, first, can we agree that this is in standard form? So let's identify A, B, and C. What's A here? It's -1, and that's important. That's really important here. B is 2, C is 3. What can I already answer on the right side there? Okay, what's the y-intercept going to be? 0, 3. Very good. Maybe even easier than that. What else can I already answer? Okay, what's the domain going to always be? All real numbers, also known as negative infinity to positive infinity. Okay, what would you want to answer next? Okay, up or down should be a pretty easy one. Is this going to open up or down? Why down? Because A is negative, so it's going to go down. And because A is going down, is this vertex going to be at the bottom or at the top? And because it's at the top, that means I have to add a max. We have 3 unknowns still left there, but all of those rely on the vertex, so I have to find the vertex. Vertex is h comma k. Let's start off with h. Formula I gave you for h is negative b over 2a. b is 2, so negative 2 divided by 2 times negative 1. What's negative 2 divided by negative 2? 1. What I now know is I know my vertex is going to be at 1 comma something. And I actually know that my axis of symmetry is going to be at x equals 1. Whatever h is, that's what gives you for axis of symmetry. But I need to know k, and I need to know my range. Now, actually, part of the range I know, especially if you're gonna write this in interval notation, I actually do know part of the range. If this parabola is opening down, is it gonna go forever up or forever down? Forever down. So the infinity I want here is negative infinity. That would be on the left side. I just don't know how high it's gonna go. Well, however high it's gonna go, I need to put a bracket because it will touch that point. I just don't know what that's there. So whatever I end up putting here for k, I'm going to put the same thing there for the range. What's the number I want to plug in to find k? It's not a negative 1. Here it's a positive 1. So 1. Then a is negative 1, b is 2, and c is 3. K is going to end up right here. You don't have to draw a little box. This is more for a visual. The first thing you do is drop a below the line. So here I'm going to put negative 1. What do we want to do next? Multiply. Every time we multiply times Rapunzel. What's 1 times negative 1? Negative 1. Then to go straight back down, we add. What's 2 minus 1? 2 minus 1 is 1. Then what's 1 times 1? 1. And then finally on the last line, 3 plus 1 is. I now know that k is 4. So that means I'm going to have a 4 here, 1 there. Okay, so now let's graph. My axis of symmetry is at x equals 1. So I would get a line and draw a vertical line right through 1 on the x-axis. Where is the vertex going to be? The vertex should be on that top of that somewhere. Where is it going to be? Where is the vertex going to be at? At 1 comma 4. So I go 1 to the right and 4 up, and there's my vertex. 1 point down, 4 to go. Do I happen to be lucky enough to have any other points here? Sometimes you will, sometimes you won't. Are there any other points that don't belong on this graph? The y-intercept, where's the y-intercept at? At 0, 3. And if I use the axis of symmetry, this particular y-intercept happens to be 1 unit away, so I would go 1 unit away on the other side. Now I have 3 points down. 2. I would like 2 more points. To find those other 2 points, so I'm going to have to go further away from the vertex. Now we'll just assume that we're going to go to the right. So the question, I've already gone 1 to the right. So the question is, do you want to go 2 to the right, 3 to the right, 4 to the right? How many points make up a parabola? An infinite amount. But I'm just asking you to draw 5 of those. So we already have 3, you only come up with 2 more. Unless you want your graph to get really big, you're probably better off just going 2 points away. So I'm going to, just like last time, start off with a 2. What's the first thing I do to the 2? And that 2 means that's implying we're already stating, hey, we intend to go 2 to the right. What are we going to do to that square? Thank you. We're actually going to square it. Okay, whatever you get, you're going to square it. And then you're going to multiply times a, which is -1. What is 2 squared times -1? 4, -4. Which means I'm going to go 4 down. So I will go up to my vertex, go 2 to the right, go 4 down. That actually puts me on the x-axis at 3, 0. And once I get there, I know that's 2 to the right, so I would stay even with that and just go 2 to the left from the axis of symmetry. Connect the dots. This is just a sketch. You can't get perfect. We don't have time to use a ruler here. Not as nice as one of Jair's sketches, but any other questions there? All right, we'll continue tomorrow. We'll get through 2 of these. If you want to practice some more of these, I don't think there's any of these on this week's homework, but you can start working on next week's homework already if you want to practice some of these. Yeah, they're sending you more free stuff.